Hill climbing search. In these, they are classified to types to show on the screen. Number 1. One simple hill climbing search. Take a graph like on the screen. 1 is an initial state. 8 is a goal node. Remaining nodes will be passing from initial state and they end at the point is goal node. In these search graphical artificial intelligence AI will be checks every node. Then AI aim to process in these way to reach goal node. In these manner AI checks initial state to the current states. Initial state is one current states will be passing nodes from initial node 1. Whenever in the current state the searching problem is solved by and using then they quit then the current state will be represents to show goal state and they can't pass another current state to search and solve by the given problem. Number 2 steepest ascent hill climbing search. It is a best algorithm to find the best solution from upon depending question. In these second type of search, they checks each and every current states to solve in an loops manner to get output solution. Otherwise, they directly reaches to goal node to end the climbing search to show the given problem solution. That's it. Hill climbing search is a heuristic search algorithm used in artificial intelligence to find the best possible solution to a problem. It starts with an initial solution and iteratively moves to neighboring solutions that are better according to a predefined heuristic evaluation function. The algorithm continues until it reaches a solution that cannot be improved upon or until a specified number of iterations is reached. One advantage of hill climbing search is its simplicity. It's easy to implement and understand compared to more complex search algorithms. Additionally, it can work well in situations where the search space is relatively small and the solution space is relatively smooth, meaning there are few local optima that could trap the algorithm. Finally, hill climbing can be computationally efficient, especially when dealing with large search spaces where exhaustive search is impractical. Despite its simplicity, hill climbing has several disadvantages. One major drawback is that it can get stuck in local optima, meaning it might find a solution that is locally optimal but not globally optimal. Additionally, hill climbing is sensitive to the initial solution and the choice of heuristic function, which can lead to suboptimal solutions or even failure to find a solution at all. Another limitation is that hill climbing doesn't guarantee convergence to the global optimum, especially in complex and rugged search spaces. Finally, it's prone to getting trapped in plateaus, where all neighboring solutions have the same heuristic value, causing the algorithm to stagnate. Hill climbing search has various applications across different domains. 1. Optimization problems. It can be used to find optimal solutions in optimization problems such as scheduling, resource allocation, and logistics. 2. Game playing. Hill climbing can be employed in game playing algorithms to make decisions for moves that lead to a higher chance of winning, such as in chess or tic-tac-toe. 3. Machine learning. It can be utilized in certain machine learning algorithms, such as training neural networks by adjusting the weights to minimize the error between predicted and actual outputs. 4. Robotics. Hill climbing can be applied in robotics for path planning and navigation tasks, helping robots find efficient routes to reach their destinations while avoiding obstacles. 5. Natural language processing. In NLP, hill climbing can be used for tasks like language generation, where it iteratively improves the quality of generated text based on a predefined evaluation function. These are just a few examples, but hill climbing can be adapted to various problem-solving scenarios where finding an optimal solution is crucial.